All right, in this video, I have a long name for this video, but what it comes down to is we're solving quadratic equations by factoring. This is the normal factoring. There's no special thing about it. This is just the first part of factoring quadratic equations that we do. There's a bunch of special rules, but I'll get to those in later videos. So we include this part about leading coefficient of 1. Well, this is the standard form of a quadratic equation, and that a is the leading coefficient. So just a is always going to equal 1 in this video, always. And see here in my example, a is 1, so we just blank there. All right. Now, what are we doing when we factor and solve for x? We are solving for when y equals 0. Why are we doing that? Why do we set y equal to 0? Well, just like our other functions where we have y equals mx plus b, we have our output is y and our x is our input. Now, with mx plus b, we know that b is our y-intercept, right? Well, it's kind of the same thing here, only c is our y-intercept. Because what we do is we just substitute 0 in for x, because along this line, x is 1, 2, 3, 4, negative 1, negative 2, negative 3. Right here, x is 0 all along this line. So we just put in a 0, x squared plus 0, x. 0 plus 0 is 0, so we're just left with c every time. So there's our y-intercept. But we don't have a line here. We don't have a nice slope, just constant slope going down or up, or, just straight line. No. Here, with this quadratic equation, we get a parabola graph. And that's why we're solving for x by setting y equal to 0, so that we can find both of the x-intercepts. So when we found the y-intercept, we set x equal to 0. But when we find the x-intercepts, we set y equal to 0. With me? So, what do we do now? Well, there's a special way to go about this. And it can be complicated for some people, but once you get it down, once you practice it enough, it'll come to you like that. So, what we want is to list the factors of c. What is c in this problem? It is negative 6. Okay, what are the factors? What are factors? Any numbers that multiply together to get that number. So negative 6, what multiplies to get negative 6? Well, you can multiply it by 1. So 1 and negative 6. And I'll get to why I'm listing all these right now. Negative 1 and positive 6, that works. So negative 1 times 6 is negative 6, yeah. What else? 2 and 3. 2, negative 3. Negative 2, positive 3. Is that it? That's it. That's all of them. Now, we want the factors of negative 6 that add together to get b. What is b in this case? Positive 1. It's an understood 1. Okay, so let's just add these together. 1 minus 6, right? Because it's 1 plus negative 6, or 1 minus 6. So it's negative 5. That's not b, which is 1. Negative 1 plus 6 That's positive 5. Still not our b that we want. 2 minus 3 is negative 1. Oh, so close. Negative 2 plus 3. There we go. That's what we wanted. Okay. That's not our answer. Why did I circle that? Because it's important. Maybe we shouldn't circle it because we don't want the teacher thinking that's our answer, because that's not even close to our answer. We're not done yet. This negative 2 and positive 3 is close to our answer. We're going to use these to factor this out. Now, what we're doing here is the opposite of the distributive property. You remember the distributive property of two binomials? You kind of FOIL these out, right? We're doing the opposite. We're taking this AC plus AD plus BC plus BD, that, and we're factoring it and going backwards. We're going back to these two binomials. Now, when we have the leading coefficient of 1, there's a very easy part of that. Part of this, we know that this is going to be x and x, those first two numbers, because when we FOIL it out, x times x, AC is just going to be x times x, which is x squared, which is what we started with, right? Because a is 1. So that part, we're done. Okay. Now, what about the next bit? Oh, these could be anything. Well, we actually already found them. And it doesn't matter which one is which because they both have that same x, right? So we just take the numbers that we found that multiply to get c and add to get b, and we plug them in. So one of them is negative 2, so we put x minus 2. And the other one is positive 3, so we put x plus 3. Equals 0. Don't forget that equals 0 part comes down too. Now, what did I just do? Well, I factored it. Now, the thing you got to do here, what I like to do the first few times you do this, just to make sure that you're right, is FOIL that out. Actually FOIL it out just to make sure that you factored it correctly, right? X times x, x squared. X times 3 is 3x. Negative 2 times x, negative 2x. Negative 2 times positive 3 is negative 6. Combine like terms. Always remember that part. X squared plus x minus 6. That is what we started with. So we know we did it correctly. Always good to check your work. All right. Now that we've factored it, now what do? We still haven't found x. Well, there's a special thing that happens here. Because we've divided these into two different numbers, let's say, what if we put in x equals positive 2? What would happen? Well, we get 2 minus 2, which is what? That is 0, right? And then anything multiplied by 0, in this case 5, is just 0, right? So that means that because anything multiplied by 0 is going to be 0, that we can kind of separate these two factors out, separate them from each other, and set them each equal to 0 in their own little equation. because if this is equal to 0, then this whole thing is going to equal 0. And if this is equal to 0, then this whole thing is going to equal 0. Makes sense? So now we just solve for x just like any other problem, only it's really easy because we just have a 0 over here. So it's just add 2 to both sides and we get x equals 2, right? Subtract 3 from both sides, we get x equals -3. So the answer is x equals -3 and 2. When they're asking you to, solve the quadratic equation by factoring, that's all they're asking you for. But I want to show you how you graph that. If x equals -3 and 2, well, 1, 2, that's a point. 1, 2, -3, that's a point. The midpoint is about halfway between -1 and 0, so -1/2. So, and the y-intercept is right there, right? So just say that's where that point is, that lowest point in the graph. It's very close to the median there. And there's your parabola. Because these are your x-intercepts, because y equals 0 all along this line. You graph this would be -1, 0, -2, 0, -3, 0, -4, 0, -5, 0, and so on all the way down the line. So that is why they wanted us to solve these. All right, I'll do a couple more examples and then we'll end this video. Let's start with this one on the right here. So what do? We find c, okay, that's 15, and we list all of its factors, right? Factors of 15, well, there's 15 and 1, and they're both positive because it's positive. And there's no variation on that since it's positive. We can't do, oh, maybe there is a variation on that. Can we do both of them negative? Absolutely. -15 times -1 is still positive 15, right? So what else we got? 3 and 5, I think that's it. +3, +5, and -3, -5, right? -3 to -5, positive 15. Yeah, okay. Now, we add them all together. Well, add them each together, one by one. 15 plus 1 is what? 16. And what are we looking for? We're looking for b, right? What is b? 8. 16 is not 8. -15 minus 1 is -16. That's still not 8. 3 plus 5 is 8. Yes, nailed it. -3 minus 5 is -8. But we don't need to do that because we already found it, right? 3 and 5. All right, so 3 and 5 are our numbers in question. So what do? 2 binomials, right? Both of them start with an x, because x times x is x squared, right? And we just put one of these numbers in one and one in the other. Now what do? We set them each equal to 0 in their own little equation, because if either one of them is 0, then the whole thing is 0. Now, I didn't mention this before, but when listing your answers, sometimes teachers will prefer that you list them in order from least to greatest. So -5 is less than -3, So I put negative 5 comma negative 3. So x equals negative 5 and negative 3. Okay? Some teachers might just accept this. X equals negative 3 and x equals negative 5. That's fine too. All right, now let's do the other one. What is C? Negative 21. What is B? Negative 4. Well, there's 1 and negative 21. There's negative 1 and positive 21. What else? 7 and 3, right? 3 and negative 7 and negative 3, positive 7. Don't worry, this will go faster once you get the hang of it. More practice means you just start to know these things faster. 1 minus 21, negative 20. Nah. Negative 1 plus 21, positive 20. No, that's still not negative 4. 3 minus 7. I think we got a winner here. All right. So what do we do? Two binomials. X plus 3, x minus 7. Don't forget your signs. Equals 0. Set each one equal to 0. Okay. X equals negative 3 and 7. Practice, practice, practice.